demonstrating automotive Ethernet demo using the Gettobyte technologies and the NXP semiconductor boards. As you can see on the screen, as we ping our board with an IP address of 192.168.0.200, we can see a reply from our board, and also the corresponding LEDs are blinking on our respective boards. Now let's delve into the whole video and the demonstration on how to do all of these steps. More information about this board, what all software packages we need to download, what is automotive Ethernet, what all things are there into the video. You have probably heard about Ethernet in networking, but have you ever wondered what does Ethernet mean in automotive systems? Automotive Ethernet is a specialized Ethernet technology which is designed from traditional Ethernet especially to be used within vehicles. With more rapid cars transforming to smart vehicles, from software-defined vehicles to the ADAS to the EV technologies, there's massive amount of data that needs to be handled within a vehicle, and this amount of data is transferred from within a vehicle, from one system of a vehicle to another system of vehicle via the networking protocols. And here comes the technology of automotive Ethernet. Just like there are protocols like CAN, LIN, or FlexRay, but they can't meet the desired demands of high bandwidth data and high speed data for the time critical and complex systems of a vehicle. And that's where comes the automotive Ethernet technology. Automotive Ethernet provides several benefits. One of the first benefit is high bandwidth, capable of sending data at a speed of 100 Mbps to multi-gigabit speed, enabling real-time transmission of large data streams. Reduce wiring complexities. Unlike traditional Ethernet, which uses 10 to 12 pins, automotive Ethernet uses a single twisted pair cable, significantly reducing the vehicle's wiring harness complexity, weight, and the cost. And it's an industry standard, widely accepted standards, enabling the interoperable across automotive manufacturers and suppliers. And automotive Ethernet is not just a theoretical; it's already driving innovation in the automotive industry. You will find that automotive Ethernet is at core of ADAS systems, advanced driving assistance systems for real-time camera, radar, LiDAR, sensor data transmission reception, electric vehicles like for battery management for efficient transferring of battery and the health monitoring data, infotainment systems supporting the high-definition video streams, audios, and telematics devices. Simply put, automotive Ethernet is connecting the smart and independent domains of a vehicle with each other to communicate in a high bandwidth, high speed. Understanding automotive Ethernet is great, but using it live in action is even better. And in today's video, we are gonna do that. We are gonna use the Gettobyte Autoboard version 1 kit so as to use the automotive Ethernet which is present on this board via the NXP TGA1103 Ethernet 5 to see the things in action, and also so as to you can build your own Ethernet applications and learn about automotive Ethernet from as a working professional, as a student, for your own self-learning and the scale-up. So let's get into the hands-on of Autoboard version 1 board Gettobyte technologies to learn the Ethernet technology, automotive Ethernet technologies. Now let's take a closer look at the Gettobyte Technologies Autoboard version 1.1 board, which is specifically designed and developed for the industrial and automotive applications, having the communication protocol support on board like of CAN, Ethernet, and LAN. And on the center of it, it's a powerful NXP semiconductors S32K344 MCU, having the inbuilt Ethernet MAC peripheral, which enables to use the Ethernet via the chip by just connecting the Ethernet via ICs. No need of any external Ethernet dedicated chips from the ASIC perspective. So just connecting the Ethernet via ICs via this K344 MCU, and then using the automotive Ethernet via the two terminals, we can easily access and use and build the automotive Ethernet protocol and applications. Now, in terms of the connection, this is our Autoboard version 1, and as I told, this is our main controller K344, followed by an Ethernet transceiver IC TGA1103 of NXP Semiconductors, followed by a 2-pin terminal connector for connecting the automotive Ethernet. And this is the Ethernet media converter of microchip technologies, which is used for converting the automotive Ethernet to the standard RJ45 Ethernet connection, okay, which will be connected with our with the RJ45 wire. Okay, like this one, like these two RJ45 connecting wires will be used of the Ethernet, and this one will be going inside this, and the another end of this wire will be going inside our PC. Okay, so that one can do the communication from Automotive Ethernet to our PC via the standard RJ45. So is to use this Ethernet media converter RJ45, one can buy this Ethernet media converter from the below video link description, and it comes in this pack box of Microchip Technologies. So as to use this Ethernet media converter, we need to use another cable. Okay. Android cable needs to be connected, and it will be plugged into the PC USB port, and we will just keep connecting this Automotive Ethernet to terminals. So over here you will see that upper one is the negative terminal and below one is the positive terminal. Corresponding pins are being connected to the jumper wire with our Autoboard version 1. And now we are just going to power our board. Okay. So if we power our board with like our Autoboard Ethernet, Autoboard version 1 would be connected with this USB cable over this debug port, and we will connect it via the USB PC or the Type C or the USB port of a PC. Okay, and board will start power up. Now we will connect another one, the Ethernet media converter too. Okay, and Ethernet media converter will be used for will be connected with again with the USB, and you will see that Ethernet media converter LEDs will also start blinking up. Okay, and now this is all the connections that one need to do for using the Automotive Ethernet with our Autoboard version 1 board. Okay, so only two things are extra needed with this Autoboard version 1. One is RJ45 Ethernet connecting cable, and this Ethernet media converter, and a USB cable for connecting the Ethernet media cable to our PC. Now let's get into the software. In the software installation parts for required for demo of this Ethernet Automotive Ethernet protocol. Okay, so now we have got to know about the hardware and the Autoboard version 1.1 board, and also bit about the what Ethernet is, why is it needed, and its feature and its support on the Gettobyte Technologies Autoboard version 1.1 board. Now let's get into real action about the software installation that is required to use the Ethernet peripheral of the Autoboard version 1.14 1.1 board for the S32K344 MCU. For doing so, in a couple of last videos of Gettobyte Technologies, there is a video of getting started with NXP S32K344 MCU, in which there is a part of the video S32 design, the software ID and the RTD package installation. Kindly watch out this part of this video. The video link will be in the description, as in this video you will get to know about the ID installation and the RTD real-time drivers software installation that we will be using for this board in all our subsequent videos also, and that will also be used for the Ethernet package. Okay, now in this video what we are gonna do is we are gonna run the Ethernet peripheral of K344 MCU via the TCP IP demo example, so as to run the LwIP demo examples on the K344 MCU via the Ethernet protocol. And for doing so, we need to download certain extra software packages apart from just the RTD installation that I am telling you for that we have done in the last video of, so for setting the K344 MCU. Okay, and for doing so, we will be needing to install certain number of extra packages. Okay, and those packages are gonna be of the one FreeRTOS package and the TCP IP stack package. RTD you guys have already installed from from this last video, and if anybody need this folder, so this folder zip file will also be in the video description link, so that they can get directly. Otherwise, if anybody wants to understand the process of installation from the NXP website, so those can follow now. So now if you will go to the NXP S32K3, okay, product page of the NXP website, over here you will find there is, in the download section, you will find S32K3 standard software. Just click onto it, S32 standard software, and it might ask you first of all to log in before showing you to the page that it will be showing you right now in the video. So you guys can log in, and by creating your account at the NXP website, that we have also instructed and guided onto this getting started with the S32K344 MCU video as well. Now coming to over here, okay, so it will be now showing you the list of all the software packages that one can download for the K344 MCU or the S32 K3 MCU family. Over here you can see that there are so many the softwares. Out of these things, the one which we have already done is RTD real-time drivers for Cortex M. fire in this video for the RTD installation. Now the next couple of packages that we'll be needing is the FreeRTOS package and the TCP IP package, as I have told you by showing you this folder. And we have to download these things, like we can download, we need to download FreeRTOS package and TCP IP package. And the compatible version numbers also has to be taken care of, as the RTD that you guys must have downloaded from the previous video is of RTD 4.0.0. Now with RTD 4.0.0, we need to download the FreeRTOS of 10.6.0 and TCP IP of 1.0.0 version number. So that is what we are gonna do. First of all, we are so onto this page, you will go to the automotive software S32K3 stacks, and once you click onto it, you will find that there are a number of stacks that are supported on S32K3 related to LIN, SDHC protocol, or the TCP/IP protocol can be seen over here. Out of this, the one which are of a concern is S32K3 TCP/IP 1.0.42401. This is what we are gonna click onto, and we are gonna download its update site zip file. Just click onto it, and its zip file is gonna start downloading, and we are going to update this, like use this update site zip file into our design studio for installation of TCP IP software package, which is compatible for the S32K344 MCU. Also, one can check out its release notes, like clicking on the release notes PDF file, and over there they can get more information that for using of this TCP IP package, what all software packages are needed. So as one can see, if we go to the TCP IP, so we need the S32K3 RTD 4.0.0, that is we have already downloaded, and the FreeRTOS 10.6.0 version, that is what we are gonna now download after this step, because we want to run the TCP IP demo packages. So that is what first of all we have downloaded. We have downloaded its release notes and get to know that okay, which all software packages it is gonna need for the K344 MCU. Okay, so RTD is gonna provide us with the Ethernet peripherals and the RTD files. FreeRTOS is going to provide us the OS that will be needing to run the TCP/IP and LwIP demos. Now going to the TCP/IP, like the next thing, the TCP/IP we have downloaded onto our zip file. Okay, that one can see also into their downloads. Clicking on seeing the downloads. Now we are going to download and search for the FreeRTOS files. For doing so, just go to the search of NXP and search the reference standard for S32K3. Once you will search onto it, so you will find one of the first link in the after the search only about the this thing as the reference standard for S32K3 MCUs. Reference standard is not reference standard, but it has to be reference software. Okay, so there are two, like NXP has divided the software packages for K3 into group standard software and the reference software. So it's from the standard software, these are our files, the one SLD K3 stacks. Okay, so these are all of our this standard packages, okay, in which there are RTD files, HSE files, hardware security peripheral files, and all these files are there. And then there is a reference standard, okay, that is what we are gonna now dwell into. This one, okay. So we'll click onto the reference software. Sorry, not standard. So you will find that there is a reference software in which there are all other and extra software files like of FreeRTOS, Mbed TLS, NXP RTOS, Z4 RTOS compatibility, and all these things. Even the AWS, the IoT core files, and the AVB software, which are like the time-sensitive network applications for the Ethernet. So out of these things, we are just right now going to concentrate on the STD-K3 FreeRTOS, because that is what our TCP/IP packages and the demo needs it. So going to the FreeRTOS, out of this, we are just going to select our TCP FreeRTOS 10.6.0 version, 4.0, 4.0.0, like main is 10.6.0. Okay, and we are gonna download its update site as well in it. And if one go to the FreeRTOS release notes, okay, so you will get to know that what all dependent files are required for using the FreeRTOS standard packages. So as it says, installation of Design Studio 3.5, that is we have done already from our getting started video. Then development packages also has to be installed. This one we have also covered from my getting started video. And then the RTD of 4.0.0 for the S32K3, and that is also we have covered. So two extra packages that we'll be needing is of TCP/IP and the FreeRTOS. Okay. So now we have downloaded both the softwares of TCP/IP and the FreeRTOS. Now we are going to install this in our Studio Design Studio, and we have to install them in a chronological way. First of all, FreeRTOS has to be updated on the Design Studio, and then TCP/IP. And how we are going to do is we will go to the Design Studio, and I hope you guys have already installed all these, like just first of all going on to the portal packages you must have already installed. Okay, so it will take you like for first of all couple of times, like minute. Okay, so yes, so now yeah, it is just loading. Okay, so now it is. So now if we will go to the installed one, so one can see what all installed packages is we have already downloaded for the Studio K3 or the for the corresponding controllers in our Studio Design Studio. In your case, you will be able to see the RTD package, okay, of Studio K3 of 4.0.0. Right now in my this is a 3.0.0 because it's my older system, but in your system you will be able to see 4.0.0 if you have followed subsequently my getting started video. Now, how to install the FreeRTOS and the TCP/IP packages? We will go to the help. Okay, we'll go to the help, and we will go to the install new software. And in the install new software, it is gonna come up with a pop-up in which we are first of all gonna select the directory. Okay, now after this, into this you need to select onto the add, and onto the add you click onto the archive, and after clicking on the archive just select the zip files that we have downloaded, okay, of FreeRTOS and the TCP/IP. So first thing that we, as I have told, we are going to download is of TCP/IP. So TCP/IP we are going to select, sorry, FreeRTOS. So just select the FreeRTOS zip file and click on the open. Okay, once you do that, you will find that it is gonna be shown over here. Okay, and click on OK. Once you click onto the OK, it is gonna be shown to you like this. Okay, select all, and you just need to then click onto the next, and then its software installation will start onto your Design Studio ID. Okay, same way you need to do the same thing by select just next you will select, and all the simple software installation will go. Right now it is gonna take time, so I'm just gonna fast forward to the video for the complete software installation. So just like you have downloaded FreeRTOS, same way you are gonna do it for the TCP/IP. And once you have done both the FreeRTOS and TCP/IP installation onto a Design Studio 3.5 by downloading the zip files and then installing new software and selecting these zip files, you are gonna see something like this now. So now after you have downloaded both the packages and restarted the Studio Design Studio, if you will go to the help and Studio Design Studio extensions and updates, you will see both of these packages, TCP/IP and FreeRTOS, as well onto your installed packages list. That is just what we are gonna now verify. Okay. So in my Design Studio, I have already downloaded and installed these things. So if you will just see and scroll over here, so we have RTD version of Studio K3 of this K3 4.0.0. Great, it's that thing what we are needing. And then in the, if you will just go over to FreeRTOS, okay, we will see yes, FreeRTOS is also downloaded of version 4.0.0, that is of 10.6.0 according to the package software that we have installed. And then if we go to the TCP/IP one, okay, so when we can just click over here. Yeah, my PC is a bit of hanging, but yeah, TCP/IP stack and it's version 1.0.04. So both of these packages are now downloaded. Now we are going to export the demo example that we are going to flash into our controller. For doing so, we will go to the new, go to the project from example. Okay, and now it is gonna just load all the demo example projects, just like in the case of Arduino Uno. On the Arduino environment, we have demo examples for the peripherals and the sensor module. Same way for the software packages that we have downloaded. For those as well, there are demo examples which are provided by the NXP. And that is what we are gonna now just see and gonna use the LwIP demo example for the K344 MCU. So it's to run the Ethernet and the TCP/IP demo. So now if you will expand onto this, we will find STU K3 access TCP/IP stack 1.0.04. controller K344, so that is what we are gonna drop down, and the LwIP bare metal S32K344 MCU. This is what we are gonna use for the current demo, so as to demonstrate. For higher versions of the demo demonstrations and how do they work, you guys can contact the Gettobyte and we can help you in more assistance of it. But for now, we are just gonna show you that simple demo of how to run the LwIP TCP and Ethernet basically on Autoboard version 1 via the LwIP bare metal STL2K344 demo example. And we will just click finish and we will just make it export to our this project explorer. Okay. And it's just gonna take a couple of minutes so as to get into it, so as to get loaded into a design studio. And yeah, so now this has opened into over here. We will just double click onto it. Okay, and we will first of all go to the .max file and open it, the double it, and we will just first of all update the code. Okay, because it's a demo project, so and Studio Design Studio has a software extension of .max file, which are like code configuration files for the K344 MCU. So we'll click onto it and update our code. Okay, similar kind of warning it might show to you. You can just overlook to it by clicking onto the OK and then moving and proceeding further. Okay, and then it is gonna open a full code configuration tool GUI, and this is we have already briefed into our previous videos of getting started with STL2K344 MCU as well. Okay, so once you will open it, so you will in the pins tool will be going to see all the pins which are being selected. Okay, for our Ethernet, and you can see the pins name and the EMAC different names like pin names EMAC TX, EX, RX, MD, MDIO, MDC, and all these things. And if you will go to the peripherals view, so you will be able to see all the configurations that are being done for the GMAC peripheral, that is the Ethernet MAC, which is there on the K344 MCU. Okay, this is GMAC, PIT, port, and the SQLT is like pins configuration, and the TCP/IP middleware stack configuration that is also being done. Okay, so right now in the demo we are not gonna go very much in depth for the explanation of demo or this thing. That is we are gonna cover in our courses of K344 MCU that is being listed at the Gettobyte website. Okay, right now we are just gonna go to the update code, make the code update, and we are just gonna flash this code, build it first of all into the design studio, and flash this code into the K344 MCU. So see the real Ethernet signals onto it, like the Ethernet working and do the connections for it. So once you have done the update code, you will see in the Project Explorer, there are many extra project files which are being generated. And if you will go to the source, and you are going to see the main.c file that is there as well in our project. Okay. Now, so as to run this code, okay, and have the proper Ethernet communication, we also need to do certain PC settings into our for running the Ethernet. Okay, so the thing that we need to do is we will go to the control panel. Okay, and go to the control panel, open it, and you can see the description.txt file in our project in this LwIP demo. And over here it is written that for please note that prior setting the PC on your PC, you might be needing the windows need to be configured, certain configurations. We'll go to the control panel, we will go to the network and Ethernet, and then network and sharing center. Okay, and then we are going to go to the change adapter settings, and in the change adapter settings, the Ethernet, which is this one, network cable plugin. Okay, so this one is the one which the Ethernet, the one which is in cross right now. Okay, because right now we have not done the hardware, this connection of our Autoboard version 1 board with the PC. Okay, right now we have just understood it. So we are going to do that once after we have completed the software thing. But just configuring before that, click onto the Ethernet network cable unplug. Okay, and go to the over here TCP Internet Protocol version 4, and over here you need to configure the IP address of 192.168.0.10, and the subnet mask is 255.255.255.0, and then click on OK, and then click on OK. So this is the important configuration that you need to do before you are ready, so as to ping your Ethernet like because LwIP example that we are gonna run is the depth ping one. Ping LwIP. We are gonna ping the our board at an IP of 192.168.0.200. Okay, and via the PC, and we are gonna see its results. Okay, as you can see over here, the expected results are that we are gonna ping this thing from our command line, and we are gonna have a reply from our automotive board K344 via the LwIP example. Okay, so make sure that you have done this setting before to it. Now go to the main.c and just click onto the build project. Once you build the project, your project will be builded. Okay, and you are gonna get the compiled file. And now after that, we will just let's move to the hardware thing. Okay, we will just now connect our Autoboard version 1 board. Okay, from the Ethernet terminals with the Ethernet media converter, and from that Ethernet media converter to the PC via the RJ45 Ethernet connecting cable. So as to have the automotive Ethernet communication with the PC with this is of standard Ethernet. Okay, and see and run this LwIP ping example that we have just now build it and compiled. Okay, so now we have built our demo code of LwIP Ethernet for the K344 MCU. Now let's just divide our onboard screen in two parts so that you guys can also see the hardware. So as you can see, this is our Autoboard version 1 board, and this is the Ethernet media converter, and which are being connected via the automotive Ethernet terminals. And this Ethernet media is connected to our PC. Okay, so let me just connect this one to my PC at once. Okay. So, yes. Okay. So now it's connected, and you can see that in our Ethernet media converter, this activity LED and this VDD main and speed, all these LEDs are being blinking, out of which activity is blinking one. And then there were reset pin, and the over here is the link LED which are being glowing. Okay. Now what we are gonna do is we are gonna flash this code into our controller. Okay, so we will just first of all configure our debug configuration via Design Studio for our code, and under the GDB Segger J link, we are gonna create a new debug configuration. So it's to flash the code, this LwIP bare metal code into our Autoboard version 1, as this board houses the onboard J link debugger. Okay, so under the J link, we are gonna got it, device name selected, executables are correct, and then we will just make it into the debug mode. Okay, so now it is going to be debug mode. This pop-up will come. You can just accept it. Okay, and now your code will be getting into the debug mode. On the meanwhile, you guys should also open. Okay, let's first of all remember my decision and switch it to the debug configuration. And in the meanwhile, we are just gonna so open our this command line also. Okay, and under the command line, we are gonna put the commands so as to flash, and let's just divide the screen in parts. Okay, so yeah, this is the one, and now our code is at main.c, and under the command line we are going to put the command of ping as it is written in the description.txt as well. We need to put the command under the command line, have put the ping 192.168.0.192.168.0.200 with a minus t. Let's put it on. Okay, so that it will be continuously pinging. Our PC is continuously pinging at this IP address, and this IP address is of our automotive Ethernet. And now, when I make this code into Go, okay, so our code will start executing, it will start running. Okay, and one can see the reply